Now the question is, how does the CNC know from where to consider the coordinate values? So the programmer will use some coordinate system. He will assume that the workpiece origin is at the end surface, or someone else may decide that it should be outside of the workpiece. Someone else may decide that it should be somewhere in the inside. So the programmer has a choice to take up the workpiece origin at any point of his choice. But how does this particular information is going to be communicated to the CNC? So for that we are having something called as the work offsets, using which we can define where exactly is the origin of the workpiece is there, and these values will be loaded into the CNC controller, and then in the program we will be specifying what is the origin that we have to consider, and accordingly the CNC will ensure that the tool is moving with respect to the coordinate system that we are uh, going to use in that particular program. Otherwise, if you are writing the program in some particular coordinate system and you have written the program in a different coordinate system, then the workpiece is going to be rejected, because there will be a distance of offset between the two origins. If the origins are same, then there is no issue, but still there will be a variation in the length of the workpiece. There may be some variation in how you are putting the workpiece in the chuck. So it is very important to tell the CNC where exactly is the origin of the workpiece is there, and from that origin it is going to make all the motions given in the program. So defining the origin is very important. So now in the CNC controller system, there are basically 3 points which are of interest for us. First is the machine reference point, that is the point which is present at the face of the spindle on the spindle axis. So you are having the chuck here. If you remove the chuck, you will be having the spindle. On the face of the spindle along the spindle axis, you will be having an imaginary point. That imaginary point is called as the machine zero point. So this point cannot be changed by the user, it is decided by the manufacturer. So this point is always going to be fixed. Then next you are having the home position. Home position is a point which is at the maximum distance from the machine zero point. So if you are taking a three-dimensional space, these two will be at the diagonally opposite sides. So the tool will always move very far away from the spindle and the workpiece. So you are having the maximum X movement and you are having the maximum Z movement, that is the maximum motions along the two coordinate systems, and that extreme position is called as the home position. Now, what is the importance of this home position? So home position is very important because that is the position in which we are going to make the tool changes, anything we want to do. Because whatever the length of the tool is there, if it is very close to the workpiece, then while you are making the tool changes, there is a chance that the tool is going to hit the workpiece and the tool may get damaged. So the tool is always moved very far away from the workpiece, and at that maximum distance location we are performing the tool changes, or we can change from one tool to another while doing the machining. So for example, you are doing the turning operation, you have completed the turning operation, now you want to do the thread cutting operation, so you require a new tool. So in the CNC there is a chance for fixing multiple tools in the tool holder, so that the CNC will automatically take up the required tools and continuously perform the operations. So whatever the tool changeover is required, or the rotation of the tool magazine is there, all these things will happen when the tool system is at the home position. There the required motions will happen and the appropriate tool will be selected or brought into the particular position. Again the program will continue to machine the required component. So this home position is also fixed. We cannot alter the home position of the CNC. So there is a particular code for that. By just recalling that particular code, we can make sure that the tool is moving straight away to the home position. So if you want to tell, that is G28, that is informing the CNC to go to the home position. Now whatever the movement is there, that will start from this particular home position. So from here you will say that this is all in the negative direction. because if you are taking this one as the origin, so this will be the positive z axis and this is a positive x axis. The workpiece origin and the machine origin will be in the third quadrant of this particular position. So all the coordinates will be in the negative. X coordinate will be negative, but z coordinate will be negative. But writing the program in terms of negative coordinates is very difficult for us, and also we cannot exactly fix the workpiece with respect to the home position or with respect to the machine 0 position. So what we'll do is we will fix the workpiece and then we will say that the end surface of this particular workpiece will be the 0. How we will do that? We will bring the tool or we will bring some dial indicator and we will come and touch the end surface of the workpiece. Whatever the readings are there in the CNC, that will say that whatever the x value is there, whatever the z value is there, that will be the origin. So that is how we are going to give the input to the controller. So the controller will remember that okay, x minus 345 or x minus 271. So this will be the origin. So whatever you write the program, it will always add or subtract this particular x and z values, so that it is always knowing within its space where exactly is the origin. So you may want to move from this point to this particular point. You may say it is 150 to 100. But in the CNC controller coordinate system, that will be completely different point. So the controller will do all these computations based on where exactly is your origin is there. So by using some simple transformation functions, that is you are only shifting the points, so you are only doing the transformations, that is translation. By simply adding and subtracting the x and z coordinates, it is able to compute the coordinates of the point in the controller coordinate system or the CNC coordinate system. We will write the program in the workpiece coordinate system, that is 0 origin what we created, but the CNC will understand the motions only in its coordinate system. So whatever the computations are there, all the things will be done by the controller. A user is not going to be bothered about all those computations, because the CNC will perform computations at a very fast rate and very accurately. You will get the required amount of accuracy. Otherwise, if you want to make these manual computations, then it is going to be very tedious. So that is about the origins, the reference points that are available in the CNC. So because of this provision of having a customized origin for any given workpiece, it is possible to write the program in such a way that we are having a much easier coordinate system. So we can have all the dimensions, all the coordinates in the positive side of the x and z axis, or maybe some coordinates we want in the positive side, some coordinates we want in the negative side. So whatever may be the requirement, we will be able to do that by fixing the origin of the workpiece. So if you want somewhere inside here, if you want your workpiece origin, then how to do that? So always the spindle axis will be the z axis. So what we'll do, we'll bring the tool or dial indicator and we'll touch the end surface. Then we'll say that this end surface should be how much. If your origin is somewhere over here, then from here to here we know the distance where we want the origin. So if you want the origin at say inside here minus 50 millimeter, then this point will be 50. Main advantages of the CNC is it is giving the user the choice to fix the origin of the workpiece at a place of his convenience. Otherwise, if the CNC does not have this capability, it is always the origin should be at this particular point. Then while setting the workpiece, we have to make sure that the program is written in such a way that this is origin is here, and also we have to ensure that this particular point is at some fixed distance from the machine 0 or the home position, so that the CNC is able to perform the operations in an accurate fashion. So it is a lot of settings will be involved, but here all those settings are completely eliminated. You just have to fix the workpiece in the check, then make sure touch the end surface and see what you want for it, whether you want a plus 50, minus 50, or you want it to 0. Accordingly give the instruction by pressing certain buttons and you will be able to get your origin. So once your origin is fixed, then whatever program you have written with respect to this origin, that is x, z, so accordingly the program will be executed and you are able to get your required component. So always we have to remember that we have to specify the origin of the workpiece, so that any operator if he wants to machine that particular component, he will know where exactly is the origin. So whether it is inside, whether it is outside, or where exactly is there, that has to be properly indicated. So that is another important thing to remember while we are doing the CNC programming.